This is the video solution to problem number 27. So I've got a barge floating in the water and then a truck rolls on top of it. And when this happens, the barge sinks farther into the water. The question is, what's the weight of the truck? And we can tell that by the hole that's created by how far the barge sinks underwater. So when it sinks in the water, it creates a hole in the river or wherever it's sitting. And all I need to do is figure out the weight of the water that would fill up this hole that's created by the truck. So that's my goal, figure out the weight of the water of the hole that's filled up by the truck. So this is the amount, the additional amount that the barge sunk underwater. It's not the total size of the barge, it's just the additional amount. So 0.04 meters by 6 meters by 4 meters. If I look at this, I can look at a free body diagram of what's going on. I'll start with the free body, that'll be the barge itself. And the barge isn't moving at all up or down, so constant velocity, which means no net acceleration. So in this case, the buoyant force going up is equal to the weight of the truck going down. So that's great. We'll use that in a few minutes. Now let's list the givens that I know, which doesn't look like much. I know the dimension of the barge that's underwater, that's the hole that's created, and that's the volume of 0.96 meters. Again, that's the hole that the barge created. And I know the density of water is 1,000 kilograms per cubic meter. Now let's look at the free body diagram. I know the sum of the forces in the y direction is equal to 0 because I'm not accelerating up or down. So in this case, the buoyant force is equal to the weight of the truck. And that buoyant force is the weight of the water created by the hole when the truck rolled on top of the barge. So in this case, I know the buoyant force is equal to the weight, which is equal to mg. So rho vg is the buoyant force, and that's equal to mg, and weight is equal to mg. So therefore, rho vg, that's the weight of the water that's created by the hole, is equal to the weight of the truck, and that'll be the answer to my question. So rho vg, rho is the volume that's underwater, it's the size of the hole. I'm sorry, that was v. V is the size of the hole. Rho is the density of the water, and of course times 9.8. And that tells me the weight of the truck is 9,408 newtons.